Everyone, hello. Good morning. It'll be a collaborative project presentation, so I'll be talking around 5 minutes. How we did about conservation agriculture in different part of AKRSPI program work, while Bhaskar is being associated with this intervention since the beginning of the inception. So we'll be talking more about the results part. So our work in 3 different states, Gujarat, MP, and Bihar. I'll not go much detail into it. Surely you can go through the website. And our major programs around natural resource management, institutional building, livelihood enhancement, and drinking water, alternate energy, primary education. And what we do in core agriculture program is solar-based irrigation, crop intensification, organic farming, INM, IPM, conservation agriculture, farmers producer company, and mechanization of smallholder farmers. I think many of you are very much aware about it, so I'll not go much detail into it. So how a healthy soil looks like. So there's this photograph you can see. You have cover crops on the top, you have earthworms, you have all different sorts of biology working in a healthy soil. And relating to this healthy soil, how conservation agriculture comes into the picture. So what conservation agriculture is. So in a previous day, Abhijit was also talking about how tillage is harmful for soil, and Tyagiji was also telling about zero tillage in his farm. So basically, conservation agriculture has 3 principles, which includes minimum soil disturbance and on a continual basis. It's not that one time you're doing it; it will be on yearly. Every year you're not disturbing the soil. You're just sowing the seeds or you're planting the saplings. So second important component of this is covering the soil permanently. You're not using any sort of plastic cover here. We are talking about the residual cover and the cover crops, which are, of course, it can be weeds uprooted from the crops itself, or maybe it can be cover crops grown along with the main crops. And third, which is very important, is it's totally against the monocropping system, which was part of the Green Revolution technology and Green Revolution paradigm. We are talking about biodiversification of cropping system, which include cropping rotation, intercropping, border cropping, mixed cropping, and all sorts of integration of crops. So why AKRSP decided to promote conservation agriculture? Since our region is like Dangs and Madhya Pradesh region were like very vulnerable to soil erosion, since there are undulated patches. The monocropping was very prevalent. Our soil conservation activities were largely limited to bunding, field bunds, and other interventions, and we could not achieve it on a sustainable basis. And these regions are very highly intensive in rainfalls, particularly Dangs. So we could see a lot of water coming with the soil and disturbing it. So small window for transplanting of rice. So farmer used to have a limited duration of time for transplanting rice. So farmer was talking about what are the alternates which they can get to transplant the rice or paddy. Sorry. So unpredictable weather, which is now very, which is a looming problem for all the agriculture, stakeholders in India. So I think thinking about these aspects, we thought of promoting conservation agriculture. And how does CA fits in to overcome all these challenges? So these are the findings which are our own experiences over the period of 3 years, as well as many of the research documents have covered it, since it reduces the soil erosion. Since you have residual cover on the soil, it improves the water infiltration rate, it reduces the soil compaction, reduces evaporation, enhances soil organic carbon, and so on and so forth. You can go through, and it also suppresses the weed, which we have seen personally. Maintaining permanent cover on the soil reduces weeds to a large extent. So we are not killing the weed, but then we are trying to suppress it through the cover crops and other biological manner. And very important, time, energy, and money of the farmer is saved by conservation agriculture. And conservation agriculture is scalable, and it can be done anywhere as far as our experience is concerned. So given about the numbers, facts about conservation agriculture, it is also promoted by FAO. And you can have a website of particularly related to conservation agriculture. And these are the facts and figures. 79% of the cultivable land of Prague Paraguay is under conservation agriculture, and largely the farmers are small and marginal. So this can be an example which we can follow. So what was the extension strategy which we adopted here? So we identified the innovative farmers, and then we selected some testing sites. So we are not going on a complete scale, since we are also learning all together with the farmers. So we innovated with the farmers, set up the testing sites. So we were practicing the existing cropping patterns based on the soil, and based on the peer learning, we are expanding it to the other farmers. So every innovative farmers have another 20 farmers, so who can learn all together, and then the scale is happening. And the major important factor which I want to bring your concern toward is the mechanization part is very important if you want to scale it on a larger scale. So these are the implementation approach. On the first year, we were just focusing on training, piloting, and making a soil baseline and field days of the farmers. So we had limited number of farmers in the first year. In second year, we had more demo plots. So there are testing sites, then we have demo plots. So what are the learnings of the testing sites? We are taking it to the demonstration farms. And from the demonstration farms, we are taking it to the larger extension level. So now in the scaling year, many donors are coming up to support us, including NABARD, Ajim Premji, BRLF, and AKF, and C&A Foundation. So what are the coverage of crops which we have so far experienced in MP, Gujarat, and Bihar? You can go through. I can share the PPT anyways. So these are the photographs from different crops. So you can see the mulch cover on the field, onion, cauliflower, brinjal, gram, and agronomic practices. So test site preparation, we prepare test sites. So the idea is, so where we have undulated patches of land, we try to do it on a permanent raised bed. Since Dang is having a lot of high rainfall intensity, so we don't want the crop to suffer the high intensive rain. So we are doing it on a raised bed, while in MP we have a different way of doing it. We're doing it on a flat bed, and we're doing basin sowing there. So how we do the zero tillage? So we are not disturbing the soil at all. We are trying to plant the trees using basin sowing. You can see this dribbler, which is like a frame which puts holes, and the farmer can, it is very good for small and marginal farmers. But of course, for the large farmers, we are thinking about new interventions. So you can also see a jab planter here, which can sow pigeon pea and other bold seeded crops like maize, pigeon pea. And there is another model of this which can also transplant the saplings of vegetables. So these are the mulching. We are supporting farmers in beginning of first and second year of bringing in mulch from the outside, and we also supporting in the cost factor, since mulch is not available particularly in Bihar and in Gujarat. So it is a very important factor to bring in mulch in the beginning of the year. We are also trying to promote gliricidia here, so that gliricidia plant will increase the biodiversity of the farm, as well as the gliricidia can also be used as a green manure in the farm, and it also keeps away the rodents like crabs and squirrels and rats, so and so forth, which we have also experienced in the as a challenge. So talking about the measurement of results, I think Bhaskar will be good. He has better experience in the field. Yeah.
Well, Gurpreet, thank you for the presentation. I am continuing with the measurement results which I got from the field areas with the farmers. There is a quantitative and qualitative comparisons and lab testing for the soil health indicators, which I will show you, the visual assessment of the soil, and the crop growth which we had conducted with the few farmers, and last the farmers' feedback we will show you. So coming to the next, the soil health is indicator which from the lab we had showed that the soil moisture had increased by the 14% here, and the bulk density has reduced by 2. So this is the aggregate, the soil aggregate stability, which compact the soils to hold the moistures, and the water infiltration very much increased by 66% in this, and of course the soil organic matter content is also increased by 41%. So this is the indicators of the qualitative where the field from the field level we can analyze the data with the farmers itself, and the farmer shows after experimenting all these things by the earthworms, organic matter content, root residues, subsurface compaction, soil tilth, and erosions, which has been shown in the field itself. So we can see in the pics the better farm ecology, what the earthworms are coming, the improve in the soil color and the textures, and the return of the earthworms is coming back on the soil, on the CA plots itself. So this is the one we had compared uh, uh, the things with the CA and the non-CA, means the traditional and the CA plot, in which we have tried to show here we have dug the 1 by 1 foot of this. We have dug the soil, and then we have seen a few centipedes and earthworms which has been come up from the CA plot itself. And on the another side, this is for the non-CA plot where nothing is coming from the soil itself. Now, in this we can see the first picture shows the bulk density, because year by year the bulk density will come, it will come lower. Almost 904 grams is in from the traditional plot, this one, and 787 grams from the CA plot, and also the colors is very different because organic matter content high in this the soil in the CA. And on the next, in this we can see the porosity and the more mellowness and friability and the color of the soil which come up from the CA plot and from the non-CA. This is very hard, and when say the stoniness is showing in this with the brownish color of the soil in the traditional one. On the second, this pics these two pics are showing the subsoil while having a creation of the hard pan layer, which is showing from the traditional. So you can see there is a hard pan here, which indicate that if the water if the moisture cannot percolate beyond this subsoil. But in the CA plot, we can see almost 12 inches of the scale, the meter. There is no hard pan is created till it has been observed. So this is actually the hard pan creates because every year the plowing in certain depth, it creates the hard pan of the soil in the traditional one. And final one is the maize crop root, which we are observing that this is the CA root from the CA plot. The maize has been it is vigorously grown, but in non-CA there is a little bit bent due to maybe the hard surface of the soil. So you can see the figures. Then again, in the visual field assessment, having the good organic matter content or the root residues has been recognized in this, and in this one, these three pics are showing the non-CA plot where the erosion took places almost 3 inches depth, and we see the cracks due to the sunlight, due to non-cover of the mulch. One thing is more, we have seen, we have recognized the macro organic matter flotation. We had collected the 1 liter of bottle, and we collected topsoil and we place it for the 24 hours for the CA and non-CA. So here we are seeing that few soluble minerals are still in the color of the water is different from the non-CA, and the flotation of the organic this matter is high comparative to the non-CA plot. Yeah, okay. Just 5 minutes more. Sorry, 2 minutes. 2 minutes. We are not focusing on the soil itself, but also we are focusing to the plant growth also. So where here the data is showing the increase in the yield potential, where the data has been recognized with the gram and the maize, 185% in increase in the gram and 62% on the maize. And the reduce in the number of the irrigation, farmers had said that they had reduced the irrigation by 2 or 3 in numbers in irrigation. Then reduce of the cost of production is also reduced by the 14% in the maize, and similarly the bigger size cob, maize and peas has been observed during the visit. Here is the increase in the biomass also has been tested, where the 60% in the maize and 56.2 in the gram has been find the biomass content of the in CA and non-CA. There are the pics available for this one is for maize and another one is for pigeon pea. So this is the plot for this year only for Rabi 2016. And this farmer has made by his own interest, and he has put a lot of mulching in his wheat crop. And this is this year's plot developed by him, newly plot developed. And another one is from Rufata village, from another village where farmers has been exposure for the CA and non-CA plot.
I think key challenges which we faced in this intervention, we have just two more slides, challenges and the policy implications. So the tillage paradigm is one of the biggest challenge when we go to the farmers and we talk about, not tilling their land. Farmers' perception about CA as a successful or non-successful, intervention, lack of implements, very important. Mulching material, again, very important factor. And infestation of rodents, which we have seen, and we have also found a solution while working with it. Gliricidia is the solution. And site specificity. What works in MP will not work in Gujarat. What works in Gujarat will not work in Punjab. So it has a lot of site specificity. You have to adopt test sites and then demonstrations, and then you need to do the scale. So potential relevance of soil health enhancement and policy support needed. So it is the best way of alternate crop residue burning. So I think in Punjab, some part of the Punjab, zero tillage is being practiced, but no continuous zero tillage has been practiced. And you can see the implement. It is happy seeder, which can plant, in all sort of crop residue, even in sugarcane bagasse. And off-field composting. So I've been seeing, I'm not apprehensive about composting, but then we are talking here about bringing the residue just where it is. So not bringing it back to the, off-site and then making it, and then again transporting it to the field. So it has a lot of economics into it. So farmers also consider labor. So we have to think, about conservation agriculture here, and yes, support for the mechanization. So happy seeder can cost like 1.4 lakhs or something without the subsidy, and some of the states has not recognized it. So I think, these were all the suggestions, and thank you.
Mike, I'm Ishtiyaq, and I work with Greenpeace. My question is from Gurpreet and Bhaskar. So when we were scoping in Bihar, so we found that there is a lot of stress on conservation agriculture from the government side, a lot of subsidies for equipments used in conservation agriculture. 2 KVKs were dedicatedly working on conservation agriculture. And when we approached the ICAR, RCER scientist who is working on this CISA project, so we were completely amazed to know that they are using endosulfan to curb herbs. They were using endosulfan as herbicides. And the scientists shared that they have to input 10% extra nitrogen in the soil so that the carbon nitrogen ratio is maintained. And the third thing, we got to know that there is a huge demand for mechanization, and huge implements are used in conservation agriculture. So my question is that since you are working with small and marginal farmers, so what kind of chemical inputs you are using, and what kind of machines you are using?
I think many of the questions were, funny to me. So, talking about conservation agriculture, how government is promoting and how we are promoting is completely different. We are going largely with the deduction mode of approach. And talking about the CM ratio, we are not promoting urea, we are promoting gliricidia. It's again a nitrogenous plant. So it maintains the same ratio in the cropping system, and mechanization, of course, we need it. And endosulfan, it's not a herbicide, it is a pesticide. So we are not, although we are not promoting any herbicides, we are promoting only cover crops and the mulching part. So that was one. The second thing was about the policy. So yes, government has the Paramparagat Krishi Vikas Yojana. So we have all sort of support in there. So each farmer can get 50,000 for a 3-year period, and he can have composting and all sort of things. And yeah, picking about one good thing from this presentation was from David's point of view. Of course, I was talking more about in situ composting, but yeah, of course, in many a times, like for example in Bihar, we have hard times, promoting, persuading farmers that you don't have to sell your straw to other suppliers, since they do it for producing electricity, and it is sold at like rupees 700 per quintal, sorry. So we are thinking, since EKRSPA has promoted many eco-entrepreneurs like Amrit Pani, Amrit Jal, we have promoted like 264 SHGs selling it. So we are also thinking about how this machine can be brought in and made it in an economic model so that it can be sold and it can be made at a replicable model on a scale. So yeah, that was my takeaway from this presentation. Thank you.
I'll just take a minute.
Yeah.
I did my